St. Petersburg, a historical and cultural centre in Russia, but also a centre of modern science and technology and the home of the Klopin Radium Institute.
Ladies and gentlemen, it's a pleasure to see here such a big international team.
In the framework of a NATO Science for Peace project, experts of the Klopin Radium Institute and of TNO work together on the development of an instrument for the detection of dirty bombs.
We attach a lot of importance to this particular project because I think it's the first project where we are really talking about explosives detection.
What you will see here is the result of a NATO Science for Peace project done together with the TNO Institute. And it's intended to detect various dangerous materials, including explosives, dangerous chemicals, and fissionable materials. It uses neutrons and gamma rays in various combinations to detect these substances.
This project applies a technology called neutron in, gamma out, which means that we are applying a nuclear technology to find out what material is hidden somewhere behind a wall, in a suitcase, or somewhere where we cannot see it at a certain distance. It can simultaneously detect the presence of an explosive and radiological material, which together form what we call a dirty bomb. So this technology is the latest development in detection of dirty bombs.
The main part of this equipment is a neutron generators to irradiate some suspicious object by neutrons, and gamma ray detectors to detect the secondary gamma rays, to detect explosives and other dangerous chemical materials, and also neutron detectors to detect fissional materials.
This is the measurement device. Now it is open, but when it is used, it can be covered. The suitcase is put in front of it, and after 1 minute long measurements, the user gets a color-coded alarm on the computer screen. This time it shows it is all green. It means there are no threat objects inside. This suitcase contains a book, a pack of CDs, some electronic equipment, and clothes. If we put an explosive, TNT, inside, and then repeat our measurement, then we get a red alarm indicating there is explosives inside the suitcase. It shows the location of the explosive and estimates its mass.
We can use this to detect about 1 kilogram of explosives in luggage in a very short time necessary, let's say, at the airports. And we can do it without opening the luggage, which is also important. And we can characterize the chemical composition of what is inside the suitcase. And the thing that X-rays usually cannot do. So this machine has some unique features that we hope will be more sensitive to various objects.
The Dutch and Russian teams will continue their efforts to optimize the performance of the new equipment. Based on this work, industrial partners will produce a commercially available instrument.
There are so many things you can detect.
This NATO-Russia Science for Peace project illustrates how fundamental research, carried out in Russia for many years, is now being made available to NATO nations in a common concern for a more secure world.